Hello, I'm Paul, and I will briefly explain an introduction of data reconciliation topic. In this introduction, I will explain a little what we find in the measurement process, errors that may arise in these measures, and how we can reconcile the variables. I also explain the classification of these variables and the most important terms that define them. Let's start. Measured process data inevitability contains some inaccurate information. That's because we use imperfect instruments to obtain these measures. Each instrument has its own accuracy that causes an error. This error can also be produced by signal transmission, power fluctuation, or miscalibration, among others. It is assumed that any observation is composed of a true value plus some error value. There are two types of error, random error and gross error. Random error is caused by one or more factors that randomly affects measurement of a variable. It follows a Gaussian distribution. The Gaussian noise is normally distributed with a mean value of 0 and known variance. Its important property is that it adds variability to the data, but it doesn't affect average performance for the group. On the other hand, gross error can be arise for various reasons, such as the miscalibration of the instruments, the measurement device failure, or non-random events affecting process, such as process leak. The error can lead to deterioration in system and the performance of this control. So it's important to estimate the true conditions of process states and in order to achieve optimal process control. Data reconciliation is the estimation of process variables based on information contained into the process measurement and models. The data reconciliation techniques allow the adjustments of the measurements so that the corrected measurements are consistent with the corresponding balances. Data reconciliation techniques started in the 1980s when plant management realized the benefits of having access to more reliable estimates of process data. Nowadays, data reconciliation techniques have been widely applied to various processing industries. Research and development have led to two major types of application. On one hand, mass and heat balance reconciliation. The simplest example is the offline reconciling of flow rates around process units, and on the other hand, model parameters estimation. Precise estimates of model parameters are required in order to obtain reliable model predictions for process simulations, design, and optimization. In general, the optimal estimates for process variable by data reconciliation are solutions to a constraint least squares or maximum likelihood objective function, where the measurements error are minimized with process model constraints. The algorithm formulated indicates that data reconciliation techniques not only reconcile the raw measurements, but also estimate a measured process variables or model parameters, provided that they are observable. It is also important to clarify some concepts. Measured variables are classified as redundant and non-redundant, whereas unmeasured variables are classified as observable and non-observable. A redundant variable is a measured variable that can be estimated by other measured variables via process models, in addition to its measurement. Contrary, a non-redundant variable is a measured variable that cannot be estimated other than be its own measurement. And an observable variable is an unmeasured variable that can be estimated from measured variables through physical models. At contrary, a non-observable variable is a variable for which non-information is available. Finally, I will thank you for your attention.